Hello everyone. Today I am going to discussing about the sequencing problem with n jobs through 3 machines. This is I will be explained with one example problem. In the problem there are 3 machines are given, that is machine A, machine B and machine C, and 6 jobs with processing time with respect to the machines are given. Let's start the solution. Here first you have to convert a problem into a 2 machine problem by the following steps. First step is find the minimum processing time for the jobs on the first machine, that is machine A, and also have to find out the minimum processing time for the last machine, that is machine C. Similarly, we have to find the maximum processing time for the jobs on the second machine, that is machine B. In the problem, machine A having the processing times are 3, 12, 5, 2, 9 and 11 for job 1 to 6. Among these values, minimum value is 2. Similarly, machine C having the processing times are 13, 4, 9, 12, 8 and 13. Among these values, minimum value is 8. And machine B having the processing times are 8, 6, 4, 6, 3 and 1. Among these values, maximum value is 8. So next, we will move to the second step, that is the check the following inequality. Here two inequalities are there. First inequality is minimum AI is greater than or equal to the maximum BI, or minimum CI is greater than or equal to the maximum BI. Here minimum value for the machine A is 2 and maximum value for machine B is 8. Similarly, minimum value for machine C is 8 and maximum value for machine B is 8. Then 2 is not greater than equal to 8 and 8 equal to the 8. Second inequality is 8 equal to the 8. So okay, next we have to move to the third step, that is if any one of the inequalities in step 2 are satisfied, this method is applicable and go to the next step. Here one inequality, that is minimum CI is greater than or equal to the maximum BI is satisfied. That is minimum CI value is 8 and maximum BI value is 8. So 8 equal to the 8. So one inequalities are satisfied. So next we will move to the step 4. So step 4 is define the two machines G and H. Here given machines are the 3, but we have to convert the 3 machine problem into the 2 machine problem. So how we are defining the 2 machines mean, here we have to define the 2 machines, that is G and H, such that processing time on G machine and H machines are given by the following relations. That is, so machine G is equal to the processing time of the machine A plus processing times of the machine B for the respective jobs. Similarly, machine H we are defining processing time of the B plus processing time of the machine C equal to the machine H with respect to the jobs. See here, machine G is A plus B. For the first job is 3 plus 8, that is 11, 12 plus 6, that is 18, 5 plus 4, that is 9, 2 plus 6, that is 8, 9 plus 3, that is 12, So last one is 11 plus 1, that is the 12. Similarly, machine H is defined as processing time of the machine B plus processing time of the machine C with respect to the jobs. So let's go for the first job. Processing time of the machine B is 8. Processing time of the machine C is 13. So 8 plus 13, this is the 21. 6 plus 4, this is the 20. 4 plus 9, that is 13. 6 plus 12, 18. 3 plus 8, that is 11. And last one is 1 plus 13, that is the 14. Here we are converted 3 machine problem into 2 machine problem, that is machine G and machine H. Next we obtain the optimum sequence using 2 machine algorithm. For this, first to draw the optimal sequence table which having the 6 columns, that is equal to the number of jobs. Here observe in the sequence table, fill the jobs for the machine G from the starting of the table and fill the jobs for machine H from the end of the table. Here minimum value is 8 for the job 4 on the machine G. Then we have to place the job 4 at first position in the optimal sequence table. Next minimum value is 9 for the job 3 on the machine G. So we have to place the job 3 in the sequence table after the place the job 4. So next minimum value is 11 for the job 1 on the machine G and also job 5 on the machine H. So first we have to place the job 1 in the sequence table after the job 3. Similarly, we have to place the job 5 in the sequence table from the last. So next we have to observe that one. Minimum value is 12 for the job 6 on the machine G. So we have to place the job 6 after the job 1. Next to last one we have to observe that one. Here minimum value is the 18 for the job 2 on the machine G. So I have to place the job in the sequence table after the job 6. Next we have to determine the total elapsed time and total ideal time for the each job. For this, draw a tabular column. Here first column is represents the job. So write the sequence of the jobs which obtained from the optimal sequence table. That is 4, 3, 1, 6, 2, 5. Next two columns are the machine A, machine B and machine C, which having the in time and out time. Here in time represents the receiving time for the respected jobs and out time represents the in time plus processing time for the respected jobs. First we have to start with the job 4 on the machine A. See here in time for a machine A, first start with the job 4 on the machine A. Here in time for job 4 on the machine A is 0, which means so machine A will receive the immediately without any waiting. Why mean it is the first job, so there is a no waiting time. So in time for the job 4 on the machine A is 0. Out time is represents the in time plus processing time for the respected job on the respected machine. So here 0 plus 2, that is the 2. So next we will move to the machine B. Here in time for the machine B is 2 hours. Why it is the 2 hours mean job 4 will be moved to the machine B after the complete the processing on the machine A. So total processing time on the machine A is 2 hours. So after the 2 hours only it will move to the machine B. So out time is in time plus processing time, that is 2 plus 6. So next we will move to the machine C. See here, in time is 8. After 8 hours only, so job 4 will move to the machine C. So in time is 8, out time is 8 plus 12. So that is the 20. So next we have to move to the job 3 on machine A. See here, in time is the 2. Why it is the 2 mean? After the 2 hours only, machine A is free. Up to the 2 hours, we are doing the processing for job 4. So in time for the job 3 is 2 and out time is in time plus processing time, that is the 2 plus 5. So 7. So next we have to move to the machine B. See here, in time is 8. Why it is the 8 mean? Up to the 8 hours, machine B is engaged with the job 4. So it will not receive the job 3. After 8 hours only, machine B will receive the job 3. So here in time is 8 and out time is in time plus processing time. So 8 plus 4, that is the 12. So next we will move to the machine C. See here, in time is 20. So why it is the 20 mean? Up to the 20 hours, machine C is engaged with the job 4. So it will not receive the job 3. So after the 20 hours only it will receive the job 3. So in time for the machine C is 20 and the out time is 20 plus processing time, that is the 9. So out time for the machine C is 29. So next we have to move to the job 1 for the machine A. So in time is 7. Why it is the 7 mean? Up to the 7 hours, machine A is engaged with the job 3. After the 7 hours only, machine A will receive the job 1. So in time for the job on the machine A is 7 hours. Out time is 7 plus 3. So that is the 10 hours. So next we have to move to the machine B. See here, in time for the machine B is 12 hours. Why it is the 12 mean? Up to the 12 hours, machine B is engaged with the third job. So it will not receive the job 1. So in time is 12 and out time is 12 plus 8, that is the 20. See next, in time for the machine C is 29 and the out time is 29 plus 30, that is 42. So next we will move to the job 6 for machine A. What is the in time for the job 6 on the machine A is 10. Why it is the 10 mean? Up to 10 hours it is engaged with the job 1. So it will not receive the job 6. So here in time is 10 and out time is 10 plus 11, that is the 21. See next we have to observe here, up to the 20 hours, machine B is busy with the job 1. So it can't able to receive the job 6. But job 6 is busy with the machine A up to the 21 hours. So it will move to the machine B after completion of the 21. See here, don't confuse here. Machine B is free up to the 20 hours only. After the 20 hours, machine B is free. But job 6 is the busy up to the 21 hours. Simple one. Here you have to compare these two values. Out time of the job 6 and also out time of the job 1. Here you have to compare. So which having the maximum value, that is you have to enter. So next, out time is the 21 plus 1, that is the 22. So next one is you have to move to the machine C. See here, machine C is fully engaged up to the 42 hours for the job 1. So after the 42 hours only machine C will be free. So after the 42 hours only it will be receive the job 6. So in time is the 42 and out time is the in time plus processing time, that is the 30. So total is 55. So next we will have to move to the job 2 on the machine A. So here in time is 21, out time is the 21 plus processing time, that is the 12, that is the 33. See here, what is the in time for the machine B? See here, machine B is free up to the after the 22 hours, but job is busy up to the 33 hours. So job 2 is free after the 33 hours only. Then only it will be moved to the machine B. So in time for the machine B is 33 and out time is 33 plus processing time 6. So 39. So next, in time for the machine C is 55. Why it is a 55 mean up to the 55 hours it is the engaged for the job 6. So after the 55 hours only, so job 2 will be moved on the machine C. See 55 plus 14, processing time is the 14. So 55 plus 14, so total out time for the machine C is 69. So next to last job, that is the job 5 for the machine A. So in time is 33, up to the 33 hours machine A is fully engaged for the job 2. So in time is 33 and out time is 33 plus processing time 9, that is the 42. So one more thing here, observe here, job 4 is fully engaged up to the 42 hours on the machine A. So it will be moved after the 42 hours. Don't confuse here. Machine B is free after the 39 hours, but job is fully engaged up to the 42 hours. So after the 42 hours only it will move to the machine B. So in time for the machine B is 42 and out time is 42 plus processing time, that is the 3. So 45. Next, in time for the machine C is 69 and out time is 68 plus 77. So total elapsed time for this sequence is 77. So next we have to move to calculate the ideal time for the each machine. First we have to calculate the ideal time for the machine A. See here, so there is any ideal time, is it? No, there is no ideal time for the job 4. Similarly here for the machine A you have to observe, after complete the job 4 immediately started the job 2, and after complete the job 2 immediately started the job 1, and after complete the job 1 immediately started the job 6. Similarly after complete the job 6 immediately started the job 2, and after complete the job 2, so then it will started the job 5. So in between sequence of the machining there is no waiting time for the machine A, but so total processing time for the machine A is 42, but total elapsed time is the 77. So total ideal time for the machine A is 77 minus 42, that is the 35. So next we will move to the machine B for ideal time. Here let's see here job 4. So initially here there is the 2 hours waiting time, that is just have to write down here. Ideal time for the machine B is initial for the initial job, so 2 hours. Next, first job is, that is the job 4 is completed 8 hours, then immediately started the another job and completed 12 hours. After that one immediately started the another job and completed at 20 hours. Then after that one, see job 1 is completed on the machine B 20 hours, but it is the receiving the job 6 after the 21 hours. So here waiting ideal time is the 21 minus 20, that is the 1. Similarly here job 6 is completed 22 hours, but it is the receiving the next job after the 33 hours. So here waiting time, that is the ideal time is the 33 minus 22, that is 11. See one more thing here. So job 2 is completed 39 hours, but job 4 is started, job 5 is started after 42 hours. So here waiting time is 42 minus 39. So that is the 3. And last one is the total processing time is the 45 for the machine B, but total elapsed time is the 77. So what is the waiting time is 77 minus 45. So that is the 32, and total ideal time for the machine B is 49. Similarly, next we have to move to the ideal time for the machine C. See here, first job it will be received after the 8 hours only. So waiting time or maybe ideal time for the machine C is 8 hours. After that one, it's a completed 20 hours first job. After 20 hours immediately started, then completed 29 hours, and immediately started the another job and completed 42 hours. After that one immediately started the another job and completed 55 hours. After that one immediately started the another job and completed at 69 hours. After that one it is completed. After that one it is received, immediately it will be received and completed after the 77 hours. So in between there is a no waiting time, and so final also total processing time for the machine C is 77 and also elapsed time also 77. So 77 minus 77, that is the 0, and total ideal time for the machine C is 8. See here, total elapsed time is 77 for this job sequence, and the ideal time for the machine A is 35, and ideal time for the machine B is 49, and ideal time for the machine C is 8 hours. So thank you.